Welcome to another video of polar coordinates. So I have explained the topic earlier. So today we'll be solving some of the problems related to polar coordinates, like the velocity and the acceleration that we derived in our earlier class. So let us start. So this is a question. So first read the question given. The position of the slider P, okay, the position of the slider P in the rotating slotted arm OA, this is the OA, is controlled by a power screw as shown. At the instant represented, theta dot equals to 8 radian per second and theta double dot equals to minus 20 rad per second square. Also at the same instant, r equals to 200 mm and r dot equals to minus 300 mm per second. R double dot equals to 0. For this instant, determine the r and theta components of the acceleration of p. So basically this is my r cap direction and this is the theta cap direction, and we have to determine this a theta and this ar. Okay, so I have drawn a free body diagram, or basically this diagram only, not a free body because you won't need this right now. So these are my given data. First of all, I've written the theta dot as given as theta dot, and theta double dot I've written as theta double dot, and also the r dot and r I have written it here, r and r dot, and r double dot is also given 0. So now we know, as from the earlier class, velocity equals to r dot r cap plus r theta dot theta cap. So here I am putting all those values, and from there I get this is my radial component and this is my transverse component. So this will be my radial acceleration, and this will be my transverse acceleration. So this was it. Okay, so here all was given, and this was a very simple problem of how to use this formula, when to use. Okay, so this is a very basic one. So let us see our next one. This is to formula putting question. So what is given? A car P travels along a straight road with a constant speed of 65 meter per second. So this is constant. Okay, so at the instant when the angle theta is 60 degree, this is 60 degree, determine the values of r dot in meter per second and theta dot. Okay, r dot and theta dot I have to calculate, and this distance is given 100 meter. So I have drawn it here. So let us see. So first of all, you have to understand the thing that if I so this is my radial direction, this is my theta cap direction. Okay, the transverse and radial, and if I break this velocity component into its radial direction, transverse direction and radial direction, I will see as v is constant, so the velocity in both these directions will be constant, which means my a transverse and a radial both will be 0, because if acceleration is non-zero, then this velocity will not be constant, but it is given that this is a constant velocity, so its component will also be constant, and that's why I have the accelerations also 0. So here I have to calculate r dot and theta dot. So basically my velocity is r dot r theta dot theta cap. Okay, and I have compared this with the velocity. So here what is the velocity? If I break this into this component, so I will get v cos 60 r cap and minus v sin 60 as it is in the opposite direction theta cap. So that is what I have written here, and I have compared these two values and these two values. So this is what I am getting, this is what I am getting. And also one thing, r, okay, so this is the r, and at an angle 60 degree, so this is 60 degree means this is also 60 degree, so r sin 60, this is r sin 60, so this is equals to 100. So that is what I have written here, and so r equals to 100 by sin 60. So using that I have calculated, so this is my r dot, and r theta dot equals to minus v sin 60. From here I have got my theta dot. Okay, so these two are very basic problems. Now let us advance to some very nice question. So here what is given, this is a satellite, and this is the z direction, and it is rotating about this z direction. If you see from the top, it is rotating in the z direction with an angular rate at a constant angular rate is given 0.05 radian per second. Okay, so, which means there will be no alpha will be 0. Okay, because my this angular rate of this is constant. Okay, this sigma is constant. It is rotating this omega, if it is constant, which means constant, so alpha is 0. Okay, and it is given that as the telescopic booms, this is the telescopic boom, are extended at a constant rate. Okay, so this is first read this one also. The length L is varied essentially from 0 to 3 meter. So this entire thing, entire thing, first of all, at the initial position, this entire thing was not there. This was inside this. This was inside this. So slowly at a constant rate, this is coming outward at a constant rate, and that so initially this was at 1.2, and this L varies from 0 to 3, which means this distance, if it is at the maximum position, this is 3. So it will slowly get out of this machine, this satellite, and that will be at a constant rate. Okay, so this is given to me. So I have drawn the one of the wings. If I am seeing from the top and I am drawing it here, so this is my free body diagram, or I have drawn all these components. This is my radial direction, this is my theta cap direction, this is the radial direction, this is the theta cap direction. Okay, because it is moving in this direction, so I have taken this one in this positive direction. I have taken along this rotating in which sense this is rotating. If I see from the top, it is rotating counterclockwise, so I have taken this one. So okay, so this is the R, this is the R from this center, and this is given to me. This one is 1.2 meter, and this is L. So R equals to 1.2 plus L meter. R double dot equals to 0. Because why this is 0? Because I have been told that R means this total thing is R, and L is moving from 0 to 3 at a constant rate. So at a constant rate means R dot equals to C. So R double dot equals to 0. If I differentiate it again, then I will get 0. So that is what I have written here. And R dot equals to L dot. Okay, here we can see R dot equals to this constant. And theta dot I have been given. Theta dot is omega. So omega, this one is sigma, is given as 0.05 rad per second. I have written. And theta double dot equals to 0, because it is also I have been told that maintain a constant angular rate. Okay, so constant angular rate means alpha equals to theta dot equals to 0. So here I have been told that the maximum acceleration to which the sensitive experiment modules P may be subjected is 0.011 meter per second square. Determine the maximum allowable boom extension rate L dot. So I have to calculate this maximum value of L dot. I have been told that this P, this thing can be subjected to if this is the A transverse and this is A radial, and so this one will be my A, and this value should not exist. This value, like this net acceleration to maximum acceleration that P can face, this should not exceed 0.011 meter per second square. Okay, so this I have been given. So I have to calculate this A radial and A theta. So this is my AR and this is my A theta. So okay, I have been putting these values. So this is the value, the R double dot. Okay, from here, so I have just put all the values here, and this is L dot. Okay, this is not I, this is L dot. So now we have to find the worst case condition. Why? Because I have been told I can apply this one when this acceleration will be 0.011 meter per second square. For that case, I have to calculate the worst condition, that is the extreme condition, where if at that condition I am getting the value of L dot, then for any other condition the satellite will be safe. Okay, so let us identify that. Okay, so see one thing, when this one was inside this, and this is slowly coming out. So at this point it will be at the maximum distance from the center. Okay, so if it is moving, this is omega, let us say this is omega. So it will face a centripetal acceleration, and also it will actually face both the accelerations at that point. So I have written it here. Okay, this one. So let us write this as, AR R cap plus A theta cap. Okay, this is my acceleration on that on this one. Okay, so here I have at worst condition. So this is my constant. First of all, let's see a thing. This A theta is a constant. This is a constant. Why? Because L theta, L dot equals to constant. This is a constant, this is a constant, this all the things is this are constant. So I do not have to check this one, but here this L is changing. L is a variable. L is a variable. So when I will have the maximum acceleration, when this L, if I write this as, if A, I have to check the magnitude, right? So A r square plus A theta square, this root equals to A r equals to 1.2 plus L 0.05 square, okay, plus 2 L dot 0.05 square. This has to be 0.011. Okay, this is our maximum acceleration. So for this maximum condition, from this maximum condition, this L is a variable. So L has to be attain the maximum value for that position at the extreme condition. So what is the maximum value of L? This is 3. So I will check at L equals to 3. This will give me the worst case scenario. Worst case. So what I will get, 1.2 plus 3 into 0.05 square, and this one will be whole square plus 2L dot 0.05 whole square less than equal to 0.011 whole square. So from here the value of L dot we will get, that will be my answer. So let us calculate that. Okay, so we have calculated this one. So the maximum value will be this one. So L dot can have maximum value of this. This is the worst case scenario. So this is my answer. Okay, so moving on to the next question. Okay, so this is a very nice question. So this may look a bit of tough for you, but this is not. Actually, if you read the question very nicely, you can solve this. Okay, so let us read it. This is I have been given the slotted arm OA. The slotted arm OA forces the small pin to move in the fixed spiral guide defined by r equals to k theta. R equals to k theta, and arm OA starts from rest at theta equals to pi by 4 when it was at rest at the initial condition here. So this angle was pi by 4. Okay, from here it has started, and has a constant counterclockwise acceleration alpha. Determine the magnitude of the acceleration of the pin P when theta equals to 3 pi by 4. Okay, so let's do this. So let us consider that at this position, this is theta is 3 pi by 4. I have to calculate at 3 pi by 4. So I have taken this. I have been using this diagram. So r equals to k theta. Okay, so theta is this one. So you can put it. And I have been told arm OA starts from rest. Theta dot dot equals to alpha. Determine the magnitude of acceleration alpha. Acceleration of the pin P. Okay, so this is my radial direction. This is my radial direction r cap. And as this is moving in this direction, so I will take this direction as positive theta cap. So I have to calculate this a theta and ar. Counting here. Okay, so first of all, what is my acceleration? ar r cap plus a theta cap, and ar is r double dot minus r theta dot square r cap plus r theta double dot plus 2r dot theta cap. Okay, so I will replace all these terms of r with theta if possible. Okay, because r is also in terms of theta. So but if r is k theta, so r dot will be k theta dot. Okay, fine, k theta dot with respect to time obviously. So r dot will be k theta dot, and r double dot will be k theta double dot. And one thing you have to notice that constant acceleration, constant counterclockwise angular acceleration theta double dot equals to alpha. So theta double dot is also given to me as alpha. So this is k alpha. So let us replace this. This will be k alpha minus r equals to k theta, and theta dot, I don't have theta dot right now, so let us write like this. This is k theta alpha, okay, this is alpha, plus 2 r dot equals to k theta dot and another theta dot, so this is square theta cap. So everything is known to me here, only this theta dot I don't know at theta dot at 3 pi by 4. So I'll calculate this one. So I have been told that initially my theta initial was pi by 4 and my theta final is 3 pi by 4, and my I was told that it was at rest initially, starts from rest, okay. So if it is starting from rest, which means my omega initial was 0 and omega final is my theta dot at 3 pi by 4, right? So this I don't know, this is my unknown, so I have to calculate this. So by the equations of motion in terms of circular motion, we know that omega final square minus omega initial square equals to 2 alpha theta, or del theta you can say, the displacement, the angular displacement. So this is 2 alpha 3 pi by 4 minus pi by 4. This is omega initial is 0, so this will be square, and I am getting here 2 alpha into pi by 2, right? Pi by 2 to cancel out, alpha pi. So theta dot square equals to alpha pi. So this is what I have got. This is obviously, remember one thing, this one is at 3 pi by 4, okay, this is at 3 pi by 4, 3 pi by 4. So I have got this one. So now I will take this equation, so, and I will calculate it. K alpha A equals to K alpha minus K theta minus K pi by 4, sorry 3 pi by 4, because theta at this point it is the 3 pi by 4, and theta dot square equals to alpha pi. This is my radial direction, and here I have K theta, theta is my 3 pi by 4, so K alpha 3 pi by 4 and plus 2k alpha pi theta cap. So I'll just simplify it. K alpha I'll take common, and this will be my 1 minus 3 pi square by 4 r cap plus K alpha. This will be my 3 pi by 4 plus 2 pi theta cap, right? Okay, I have written it correctly, I guess. Yes. Am I missing something? K 3 pi by 4, K alpha is 3 pi by, okay, no, I have written correctly. So this is it, and I have been told that maximum acceleration, magnitude of the acceleration, sorry, of the pin P. So magnitude of this A will be square of this term plus square of this term and whole square root, sorry. So this will be my K alpha root over 1 minus 3 pi square by 4 whole square plus 3 pi to the 11 pi by 4 square. Okay, so if you calculate this one, I'll get as, okay, so this is what I have calculated, and this is my answer. So this was a good problem, you can say. So like this, so I think you have understood how to apply this polar coordinate concept into mechanics, and so the main application of this polar coordinates, you will get it in rotation and circular motion. So we'll be coming up to that. So subscribe for more, and always share this channel with your friends and other JEE aspirants. So this is it for today. Bye bye.